So we're going to start with, it's got to be, this is an equation, a quadratic that moves right 3, has a horizontal stretch by a factor of 3, and it's been moved up 3. Well, I think you all know it starts with y equals x squared, but it's not quite that simple because you need room in here to show that it's been moved right or left. You need a little bit of room in front to show a stretch if there's a vertical stretch. You need some room on the inside to like show a horizontal stretch. So please turn to the kid next to you and see what you think it should be. This is one of the most confusing kinds. The right 3 isn't going to get anybody. I mean, that should be a minus 3 in the inside, okay? And the up 3 isn't going to get anybody. There's a 3 there. And I said it was horizontal, so most people know it's not going to be in front. Then the 3 has to be on the inside. But if I actually put a 3 here, if I do, I would have to have a parentheses here. Who remembered the extra parentheses? Raise your hand if you did. That's at least half of you. Good. And last but not least, would this actually do a stretch? No, it wouldn't. So therefore, you should put in a 1/3. I know it's confusing. That's the point. This is the trickiest kind. All right. But the numbers are different. Yeah, they should be. Because when this comes out, it shouldn't do what you expect. It should do the opposite of expect. All right. Let's give you another one. Let's say this one is an absolute value function this time, and it's got a 3 on the outside, and it's got a x minus 4 on the inside, and then a plus 7. There's 3 things that happen in the right order. What is the first thing that happens? What's the second thing that happens? And what's the third thing that happens? I'm going to pause for a second and you tell me the right order. So if you are supposed to start on the inside, you should, and it's right 4. Then you do the outside stuff. And the outside stuff has to be in the order of operations. And this is a times by 3 right there. So that has to be next. That's a vertical stretch. BFO by a factor of 3. If you want to write out by a factor of, you can, but I'm fine with BFO. And then last but not least is up 7. If any of those are in a different order, you're doing it wrong, unless you want to pull the, but I thought you could start on the outside. Okay, if you wanted to start on the outside, then you could move this to last, but everything else should be in the same order. Okay, that's one of the tougher ones. Now, how about a plain old-fashioned graph it? Everybody, I know you're not going to be super accurate on this, but you should be able to make me points. We won't even graph the points because you don't have graph paper. So let's just have you just give me some points on an XY table for this. Y equals 2 times 1 over x minus 1 plus 3. Now let's agree on one number that you shouldn't put in because it for sure won't work. 0 will work. 1 won't work. Do not put in 1. Why? Because when you put in a 1, you'll have a 0 on the bottom. You can't divide by 0. It's not legal. So don't even put a 1. By the way, did you know that that's where an asymptote will be? Because if the function can't exist, that's where the asymptote line is. See, the function doesn't touch the asymptote line. That's kind of the point. But if you just think of it as, I know that these have asymptotes, and the asymptotes kind of go like this. Then I'm going to move the asymptotes right. I'm going to move them this way and this way. So you can realize that, oh yeah, if I move it 1 to the right, then putting in a 1, it makes sense that putting in a 1 won't work. Putting in a 1 gives you the asymptote. Because this whole line will move to the right. All right. So 1 is not the smartest thing to put in, although it does give you the asymptote. What is something that is smart to put in? 2. What else works well? 0 works well. And it seems like we tried 1 and it kind of was weird. It was the asymptote. How about 3? Will 3 work? It actually will work pretty well. So let's just put in those 3. 0 and 2 and 3. 0, 1, 2, and 3, but 1 was the asymptote. The asymptote's at x equals 1. If you're not processing that yet. If x equals 1, there's an asymptote there. See, this is where the asymptote is. It moves over 1 to the right. All right. This will be the toughest graphing question. Because these are those weird ones. Remember, they kind of look like this. Dot, dot, and then you got to draw it freehand and get closer and closer to the asymptotes. But then this whole thing is going to move like 1 to the right and up 3. And so, yeah, this is the toughest kind for sure. So we're not even going to graph it. We're just going to answer these 3 questions. Put in 2, put in 0, put in 3. Check with the kid next to you and see if you got the same thing as they did. Okay, when I put in 2 here, I have 2 minus 1 on the bottom, which is 1. 1 divided by 1 is 1, times 2 is 2, plus 3 is... Do you guys get 5? 2 comma 5? Awesome. If you put in 0, I think you get 1. Can you agree with that? Awesome. And then if I put in a 3, 2 times a half, which is 1. 1 plus 3 is 4. I have those right? Awesome. Now, let me just show you if I had to graph this quick. Do you agree that the asymptotes would move? Let me show you where. 1 to the right for that minus 1 and up 3 for that. So then the other asymptote that I'll make in green, it's going to go up 3. And that's where my asymptotes are. They're the green ones now. Then if I graph these points, 2 comma 5, I'll have a dot for 2 comma 5, like right around here-ish. 0 comma 1 is like here-ish. And 3 comma 4 is like there-ish. Can you complete the rest of the picture? Yeah, you can. You don't need any more points. That's enough. Because you can go, I think it just has to go through these points and get closer and closer to the asymptotes. Same with this. It just needs to get closer and closer to the asymptotes. Could I have found another point? Sure. Do I have to find another point? Nope. All right. That would be about as hard as it could be on graphing. Now, let's move to, let's see, the little weird shape ones. I'm going to make this one a baseball cap. Baseball cap starts here. And then it has a bill that goes out like that. Let's say it's right on the axis, but I don't want to make it so you can't see it. So I made it just a tiny bit up. All right. So let's say that's f of x. Do you get what I mean when I say f of x minus 3? Would you talk to the kid next to you and tell him what you think happens? Would you agree everything went to the right 3? So if I took my original parent points, I want to do that now. I'm going to tell you this is negative 1 comma 0 for that spot right there. We're going to say that spot's 0 comma 1. We're going to say the top of the hat is at 1 comma 1 half. No, I'm wrong. 1 comma 1 and a half. 1 comma 1.5. I'll make it a decimal. I think most kids like decimals better. 1 comma 1.5. And this one's going to be 3 comma 0 right there. And then the last one will be 5 comma 0. Those are the parent points. Tell the kid next to you what mistake a lot of kids are going to make when they deal with the x's. Yeah, they're going to subtract 3 because they're going to be like, it says minus 3. But you got to be smart enough to go, oh, wait, I do the opposite of what it seems like. So you'd actually add 3 to all of your x's. So get that I'd add 3 here, I'd add 3 here, I'd add 3 here, and I'd add 3 here, and I'd add 3 there. And then if I do that, I have new points. And this will be 2 comma 0 3 comma 1, 4 comma 1.5, 6 comma 0, and 8 comma 0. And that would make the new hat just moved over a little bit. How far? 3 spots over. And it would look something like that when it was all done. All right. The kind that are the worst are on the inside, because not only do you do the opposite of what you would think, you do it in the opposite order of what you would think. So let's just do one more with the little hat. Okay, so imagine I said f of 3x. Don't even do it, but think, what would you do to all your x's? If I said f of 3x, what would you do to all the x's? And if you use the word divide, you fail. You're not going to actually fail the test. I'm just saying you don't want to say divide. Were you thinking multiply them all by 1/3? That's what you should be thinking. So you'd multiply this by 1/3, multiply all of them by 1/3, and you'd get your new points and you'd graph it. And then I want to ask now, what would it do to the hat? 3 times wider? No. Shrink by a factor of, not 3, 1/3. Shrink by a factor of 1/3. So it will be smaller. 1/3 means 1/3 as big. So this hat would be way smaller. So it'd be like a little tiny hat. That's still the same height though, kind of weird. But it's like the hat would look kind of like this green thing. And I'm actually off a little bit. I'm going to try that again. If I was going to make the hat be 1/3 as wide, but the same height, the hat would look something like that. It's kind of scrunched this way and this way. Okay? All right. Now, instead of just doing problems with you all hour, I think we should have a fair amount of time where you get to work on like a practice test, and if you're stuck on something that maybe there's only one kind that bothers you, you can walk up and ask. All right? So we've done a practice of all the hardest, scariest things. This is the part where we should, everybody get into the Schoology folder for today. And I'm going to pause for a second. For those at home, I decided to assign the one that was the Schoology quiz as the required one. And the worksheet that has a nice key for it, that one is optional. I do encourage you, if you ever get stuck on one of the hard ones, to go look at that worksheet that's got a key. That way you can see if you're doing it right. And hopefully you're ready for the test tomorrow.